Okay, so I'm Susan Forney, and this is my first UKNOF, and I am from Hurricane Electric, which is a company that does an awful lot of peering. We actually peer with more ASs than any other network on the planet. I also am the same Susan Forney who is a member of the NANOG board, and I am the same Susan Forney who for around 15 years worked for a small software company in Redmond, Washington, of which you may have heard. Let's try that. There we go. Okay, so today I want to answer a few questions about peering economics. First, I'm going to explain why peering is never free. When is peering worth the investment? What type of peering should you do? And why you need a peering strategy? And why you should be a good neighbor. So first, we're just going to start out with why peering is never free. The first reason why peering is never free is because it's a connection between two network devices, and network devices are not free, as you've probably noticed. People are needed to configure and maintain network devices, or at least automate, as Pete pointed out, the configuration of network devices, and people are not free. Network devices need electrical power and space to occupy, and space and power, as you know from your data center bills, are not free. So, while we've established that peering has a cost, anything that has a cost, it also has a value. So to determine its value to you, you need to figure out a few things. The first is how much your port costs. Besides the equipment, don't forget to factor in the optics, its rack space, power, and its support costs. And support costs really are important because when you're buying a piece of equipment, sometimes the support costs can cost you more than the equipment ever did. Figure out how much your cross connects at the data center are costing you and how much it costs to be on the exchange. Don't forget the setup fees for the exchange and for the cross connect. And while it's true that each of your transit providers also consumes a port and a cross connect, this is a good exercise to keep track of your costs. If nothing else, it's going to help you when it's budget time and those people from accounting come and ask you how much money you're going to need for next year. If you're keeping track of these costs, it's going to be really easy to document when you want to expand your network how much it's going to cost you. So, to get an idea of really how this works out, how this plays out, I've created this chart that shows you basically from an average ISP and an average IX, and I kind of used round number figures. Unfortunately, they're in dollars because I'm an American, but you can pretend they're in pounds or euros if that makes it easier, so that it makes it kind of easy to compare what this costs. So for a device port, for example, it's about the same. It's going to cost you the same on either piece of equipment, and it's generally around $200 if you figure out what a port actually costs you. And then a setup fee for cross-connect. I found a lot of data centers, they charged about double the price of a monthly recurring cost, maybe $500. And then the setup fee for the service. I noticed a lot of exchanges charge, some are around $500, and usually a cross-connect is about the same as one MRC, so I put in $250. And then for recurring costs that you get to pay every month, your friendly ISP is going to have a commit level. And since this is a 10 gig port we're talking about, most ISPs charge you about 2 gig. You want you to pay for at least 2 gig. So we'll say 2,000 megabits or 2 gig. And the commit price for that at $1 a megabit is going to be $2,000. That's easy round numbers, or pounds, whatever you want to say. And then the price per port isn't a deal on an ISP, and then the cross connect is $250. So then for the IX, it's a little simpler. Your monthly recurring costs are just the price of your port on the IX, which in this case I listed as $500, and the price of the cross connect is $250. So, and I kept these numbers pretty simple because we're going to use them later, and it makes it a little bit easier to figure it out. But as you can see, just as a quick ballpark, the ISP is looking pretty expensive compared to the IX. IX, you've got about $750 in monthly recurring costs, and, it's looking pretty good. So if you want to determine if your peering port is a good investment, you're going to need to know how much your transit or settled peering costs are, And so we've just gone through that and considered the committed rates, because that's important, because you get to pay those every month, whether your customers are streaming themselves silly, or whether you're just sitting there paying for the port and you're not running any traffic across it. And then you need to figure out how much traffic you could move to the peering port, because if you're not meeting your commit rate today, how much traffic are you going to be able to put on that exchange port? So to determine how much traffic you could move to the port, you should consider who your potential peering partners might be on this exchange. And exchanges where you can reach content networks or cloud providers can be very advantageous. If you are buying a lot of service from, the big cloud provider like Amazon or DigitalOcean or Google, then being able to peer with those people on an exchange is a very valuable thing. And they're willing to peer for you for exactly the same reason. They don't like transit bills either, and so they're usually really happy to accommodate you. Don't forget to peer with caching networks too, because a lot of the content that your customers or or the people on your network use comes from places like Akamai, Fastly, and Limelight. And if you're peering with those people, then you get those bits for free too, in addition to wherever they're actually putting you in the if you're going to Google or wherever they're actually going in the end. And then NetFlow or SFlow can give you a lot of information about your highest traffic sources and destinations. And if you don't use it now, I recommend it, because one time I was working with some folks at a university who were on a really tight budget, and they were trying to figure out how they were going to save some money, and they wanted to know if peering would do it for them. And I said, well, where does your traffic go? Well, they didn't know. Well, as it turned out, some friendly salesman was trying to sell them a NetFlow solution. So we quickly cobbled together on a few ports some configuration and set the collector up, let it go, and started to look at where their traffic went. And this is a university, so we're thinking a lot of other universities, research houses, maybe government, whatever. No. The bulk of these folks' traffic went to a streaming service called Netflix, and this was many years ago. I'm sure that if I looked at it today, there'd be Hulu and Amazon Prime, everything else. I'm sure would be there. But at that time, Netflix was 75% of the traffic, believe it or don't, because these people also gave network access to the dormitories in their university, and that's what college kids do in their spare time, is watch Netflix. So they quickly determined that peering with Netflix might save them an awful lot of money. But none of us, before we did that traffic study, had any idea that that's where their traffic went. I would never have guessed that in a million years, personally. So once you have this information, you can see if getting a port on the exchange is going to make some good business sense for you based on cost. So what I did is I put together a little chart, and this actually looks pretty simple. If the blue line is what your what the ISP that we talked about earlier is charging you, and the orange line is what the IX cost is, and then across the bottom I've got megabits, and across the left hand side we've got the cost. So if you look at this, it seems like a slam dunk. The IX is obviously a lot cheaper than the ISP. The ISP is very expensive until it gets to its commit rate, and then it kind of is pretty much, since it's I put the bursting charge at $1, remember, and so that was about the same as the commit rate, so it doesn't really get any less or more expensive if you burst, and it's pretty flat after that. And then the IX cost, of course, the more bits you put across it, the cheaper it gets, although, it never actually gets to be free, but it gets to be really close. So this looks great, right? But this isn't actually how it works. What really happens is this. So you have to pay that commit rate every single month. So the first, the orange line is the ISP cost of traffic at, and I'm considering that I'm putting 50% on my ISP. And then the gray line is 50% of the traffic on the IX. The yellow line is my fixed ISP cost. And then the blue line is what I'm actually paying per megabit. So you can see that these things, it isn't as simple as we once thought. If I put the traffic on the IX, I'm taking traffic away from my commit, which means I'm paying for my commit anyway. So I don't actually start to break even where I get a cost benefit from being on the IX until I'm almost at 3 gigs. And, you know, depending on your situation, it pays to think about this kind of stuff because you can actually spend a lot of money. You know, you can go broke trying to save money. So you can adjust this for your own individual situation, but at the end of the day, it pays to take a little bit of analysis and figure out what it's costing you. So now, once you have figured out, you know, what your bill is going to be and how much it's costing you out of pocket just to pay to your providers, don't forget to factor in your operational support costs. And you can save money by, as you know, Peter's just talked to us about streamlining or automating them. This is really important because if you're trying to get the most money out of a free service, then you don't really want to spend a lot of money setting it up every time. If you're manually building your peers every time you set them up, you're just wasting a lot of money. And it also is going to slow you down as it's going to slow down your enthusiasm for adding more peers. If you automate the process and make it easy to peer with anybody and add a peer onto your network, you're going to be money ahead. I would suggest doing something like creating 2 or 3 basic peer groups for your neighbors, and then all you need to know how to turn up a peer on an IX is their AS number and their IP addresses, and maybe their AS set and their suggested prefix limits, which hopefully you can get from either some place like Ripe or PeeringDB. Then consider the support priority of your peers. For example, you may not want to put them on the same priority in your BGP sessions as your ISP. You maybe don't want to wake up your engineers in the middle of the night to get a peer with a small network backup. And because it does actually cost you in the long run in terms of people if you do that. On the other hand, if you're somebody like that university and Netflix goes down, this may be a true emergency, and yes, you want to get it back up right away. The other thing I would ask you to remember is that you are billed by bursting at a 95th percentile on most ISPs. So if a few bits dribble over onto your ISP, it's probably not going to break you. So it's probably not worth waking people up for that. Then I tell you to monitor your port capacity on your IX connections and increase it before you get into trouble. And this is actually a more common problem than you think. I see it a lot every day where people enthusiastically turn up lots of peers, and then the next thing you know, something causes a lot of traffic to go across that IX link, and it's too full. So you should monitor those IX links exactly the same way that you monitor your ISP connections. And then use communities or local pref or other things to make your peering a little bit smarter. And this can help you in situations where you're trying to keep local traffic local. Listen to routes from your peers and tag them so that you only advertise them in the places where it's strategically advantageous for you to do that. Also, when you're thinking about peering, it really isn't all about the money. Peering does a lot of things for you besides just save you cash on your transit bill. And it honestly can do that, and that's probably why most people do it. But it also provides real benefits in terms of reduced latency and improved throughput on your network. If you're peering with someone like Google or Microsoft or Amazon, and you're buying a lot of services from them, and you're peering with them directly, you are going to notice a huge improvement on your costs. I actually, when I ran the Boston Internet Exchange at my last job, and the bulk of my people, of my new members on the peering exchange were on there so that they could peer with Amazon or Microsoft. Those were their two top reasons for being on the exchange, because they gain so much benefit in performance for those services by peering with them directly rather than having to go across the internet for them. So if you're looking at an exchange and you can peer with people that will give you that kind of advantage, it's going to do you a lot of good. You also gain a lot more diversity at your edge. And this is going to help you improve traffic flow and decrease latency. and can help your routers rebuild tables more quickly when a link goes down. And at the end of the day, when you're routing, the more places you're getting your routes from, the better performance you're going to get. Because if you lose somebody, it doesn't cause so much disruption. If you've only got 1 or 2 ISPs, then that means, now the internet table is at over 700,000 routes. And even if those are, routes are evenly distributed across the 2 ISPs, and I guarantee you they won't be, then when one of them goes down, you're going to reconverge at least 350,000 routes. If you're pulling, if lots of your traffic is going locally and it's going to peers, and you've diversified that, then it cuts down on the amount of reconvergence you have, and it takes a lot less time for your network to recover in the event of a little oopsie. It also improves, this phenomenon also improves the scale of your network and prepares you for future growth, makes it easier for you to get bigger because you're spread out. And your internal and external customers are going to be happier because they're going to see better performance. And, there's nothing worse than, the guy in accounting who comes in and he's yelling at you all the time because he's got some service going on, that is hosted on Amazon, and he has crappy performance, and you're ruining his life, and he's in there every day, eating up 15 minutes of your time, complaining about this horrible performance. In that case, a peering connection that gets rid of someone like that is priceless. So the easiest option you have, I guess to talk about what kind of peering to do. So the easiest option at most public exchanges is peering with the IX's route server. And this is really popular because it's really easy. Your router only has a peering session with the route server. And it's a quick way to get access to all of these networks on the exchange. And even if you peer individually, you can still peer with the route server as well, but you might want to make sure, like with local preference or communities, that you prefer the directly connected routes. The disadvantage of peering with the route server is that you have a lot less control over what you're getting. And you could filter, but at the end, by the time you set up filters that make the route server really optimal, it's probably less work just to peer with everybody individually. You also may not get all of the routes from all of the people on the exchange through the route server. A lot of people do not advertise all of their routes to the route server, so it's a little more beneficial to peer directly. And also, some networks don't choose to peer with the route server, so then you don't get their routes either. Also, not all exchanges even have route servers. But if you are trying to get something set up really quickly, a route server can be a quick and easy way at least to get started on an exchange. Peering also takes place across private direct connections in a data center. In addition, even when there's an exchange in place, sometimes people will peer because the cost of a cross-connect is going to make a lot more sense to them than peering actually across the exchange fabric. And if there's enough traffic to justify it, then sometimes that's a really good solution. Also, in some exchanges, if you're a pair of people with a lot of traffic, you can put a burden on the switch, and the exchange kind of frowns on that. So peering privately can be a good idea. As with a peer on the exchange, it can be free or paid depending on the politics of the situation and who's peering with who. And then usually the peers agree to split the cost of the cross-connect fees. Usually there's more than one peer, so somebody says, I'll pay here and you pay there, and that's usually how it's worked out. Of course, the other type of peering to do is directly on a internet exchange switch, and it's the most common and convenient way to set up peering sessions because all you need to do is connect one port, and now you can peer with lots of people. You have more routing options than you do if you peer with the route server, and once the port is in place, you can turn sessions up in minutes, which allows you to quickly increase the number of people that you're peering with. Peering across the exchange fabric can be free, or it can be, and I put this part in because of the pedantic folks in the audience, it can be paid or settled. If there are actually people who use their port on the peering exchange to peer with another network, and it's settled peering. I don't know very many people who do that, but it does happen occasionally. And it's usually because they don't believe that peering for free is of interest to them, so they come up with some sort of arrangement. So after you've determined what kind of peering you want to do, you need a peering strategy. And the reason why you need a peering strategy is because this is how you're going to get the most value out of your exchange port. Some of the things you want to consider are what networks on the exchange are going to benefit you the most. And this is a more compelling question depending on how much traffic you think you're going to get across that peering port. If you've got, let's say a 10 gig port on the exchange, and there's, if you peer with everyone on the exchange, it's highly unlikely that you will ever fill up even half of it, then, you probably don't have to worry as much. But if there are people on the exchange, if you're peering with services like Amazon or Netflix or the streaming services, and you think that is going to cause a lot of traffic, you might want to do a little bit of analysis to make sure that you're, getting the biggest bang for your buck first, and then you can peer with everybody else that you have room for later. So you need to do that analysis on what networks are going to do the most for you. Then, you need to figure out what exchanges you should join. And sometimes there's more than one option. A lot of data centers have more than one exchange in them, and then you need to figure out where you want to spend your money. And again, this is probably going to be a question of, who is the best buy for you as far as peering is concerned. Who's going to give you the most advantage, and are they on that exchange or not? But you should take a look around and see who's there. And then, how will you route the prefixes you receive in your network? And you need to think about what kind of traffic you're getting and where it's going. And again, this is where NetFlow or SFlow can be your friend, because you can see where it's going, and you can make a little bit more intelligent decisions about what you want to do. Also, you can determine if a peer makes sense for you. Do you send a lot of traffic to this peer over a transit connection? Again, this is like your streaming services. This is obviously going to save you money. Could a direct connection with lower latency have a compelling performance improvement on your network? Again, like the Amazon or like the Google folks. And do you have excess bandwidth? So these are all things you need to think about. Now, to illustrate this point, I made this little drawing about Company A and a little network. And so Company A is the green cloud, and they have an office in another country. And because it's a long way away, they have a connection back to them, and they've set up a router that gives the office a connection to the internet. And the blue network is actually in the same country as that office. And so that way the office is able to do a lot of traffic a little bit more locally than having to go all the way back to the home office through the internet and then come back. It doesn't have to double back. And so that's a good arrangement for it. But then, as it turns out, an IX comes into town, and both our AS777 and AS888, which I picked because nobody's using them, they're obviously made up, then they both join the IX because they see that they're changing traffic there, and it looks like it's going to be a good deal for them. But if they're not careful, here's exactly what can happen. Instead of, if they don't advertise their routes properly, instead of the traffic between that sales office and the local AS going through the internet with a shorter path, which might be better for them, it can go all the way through this, through the IX and back again, and cause a huge amount of latency. And I honestly, in my everyday life, see this a lot. And the way you do this is by being very strategic with your announcements about what prefixes you announce in areas so that you can control where your traffic goes. Now, in some cases, performance might be less important than cost. And maybe you want the traffic to go that way, which is great. But you should think about it before you find out that, all of a sudden you have a lot of performance issues because you turned up an IX port. So as we've seen, peering can improve your routing and reduce latency or not. If you peer at more than one location, this is why you should consider a routing architecture that allows your prefixes to be announced strategically to keep traffic local. And some peers can benefit your network more than others, and figuring out which ones they are can get you return more quickly. So now we should talk about why you should be a good neighbor on a peering exchange. Because the reason why is because peering works when it's a good experience for both parties. Clean up your advertisements. You should not be leaking your private IP space or routes that don't originate from a public IS, from a public AS, or even like /29s or whatever, to your peers. This does not inspire confidence in them. Please be easy to contact by keeping up-to-date routing information and contact information in peering DB and in RIPE and your RIR, so that it's easier for people to contact you in the event of a problem. Keep your IRR records up to date. And while the other network you're peering with is probably a fine organization, you should trust no one. Set max prefix limits for your peers. My favorite story for this is one time I was in a data center at Telco Hotel, and I ran into a guy that was crawling out of the elevator at 7 o'clock in the morning, had been there all night. And I asked him, what happened? Why were you here all night? And he goes, one of my peers tried to advertise the internet to me. And I said, don't you have max prefix limits on your peers? He said, I do now. So, this is why you shouldn't trust anyone. It's fine until it happens, and then you can be up all night trying to put your network back together. So put max prefix limits on. And filter your routes to accept routes only from a valid from valid origins and from valid paths, and deny private ISP space and bogons. And if you think that's hard, building filters actually does not have to be hard at all. You can script it yourself or use a tool like BGP Q3. I've given an example here to how you generate a list from a Juniper router, and I've used our friends from Mythic Beasts here. And as you can see, it quickly generates a list for their six IPv6 addresses, and there you go. You put it in place. You can script it. You can automate it, and it doesn't have to be hard, and it protects you. So the last thing, be responsive when you're notified of an issue. Nobody likes a peer who ignores them. No one can take advantage of you without your permission. Control the routes that you advertise so that the traffic is going the way you really want it to go. Don't rely on prepends. They don't really work. Not all networks will want to peer with you, and this usually has more to do with their peering policy than it does with you. So that's all I had to say. Does anybody have any questions?
Hi, Pete Stevens from Mythic Beasts. If you use AS Mythic, you'll get our customers too.
Okay, thank you, Susan.